Okay, we start with, so we're going to take today's lesson, we're going to build it into 2 days, okay? And we start by, so the goal today is to solve logarithmic and exponential equations. So if you look at the first example, we must answer this question. This is the question of the day. 8 to what power is 162? Somebody, what power do we take 8 to get 162? 3, very good. So we all know that that's false, right? Because everybody knows that 8 to the third power is actually 512, right?
So then what is it?
Yeah, exactly. That's the question we're trying to answer. Can everybody appreciate that we do not know right now what power you take 8 to in order to get 162? Yeah. Like prior to this class, when you walked in the door, you did not know how to do that, and now you will. Yeah. So let's solve it. Watch so you can see the genius behind the mathematics. Are you ready? Suppose I had 8x was equal to 162. What would you do to both sides? You would divide by 8, right? That makes sense. Suppose you had x plus 8 is equal to 162. What would you do to both sides? You'd subtract 8. Here's a tough one for you. Suppose you had x to the 8th power is equal to 162. What would you do to both sides? You'd take the 8th root. You'd raise it to the 1/8 power. Okay, so we've had all sorts of way of undoing things and solving. Well, what's different is now 8 is the base. So here's what we do. We take the log base 8 of both sides.
Because weren't we doing like 8 is to the left?
Yes. And we will end up converting it to a logarithm.
Wait, so then does the log base 8 and 8 cancel?
Yes. So look what happens on the left-hand side. These go away, leaving you with x equals, I wish there was a way we could compute log base 8 of 162. I wish our teacher told us how to do something like that at the end of the hour yesterday. What do? Yeah, we do that. We do log of 162, and we divide it by the log of 8.
That was 8 divided by 162.
No, that number over that number. And we get x is equal to 2.447. We're going to 3 decimal places. We're going 3. Okay, they recommend in the book, they recommend you go 6. We're just going to do 3. You good? See the genius behind it? Let's try the next one. E to what power is 2? So I have e to the x is equal to 2. I want to get rid of e. So I do log base e of both sides. What is log base e? That's natural log. So in order to get rid of a base of e, we do the natural log of both sides. On your left-hand side, we get x. On the right-hand side, we do the natural log of 2. Do you have a natural log button on your calculator? Yes, we do. Yep, so you press natural log of 2, and you get 0.693. You try letter C and letter F on your own. Ready, set, go. All right, for letter C, I've come up with 1.468, and for letter F, I've come up with 3.219. Anybody have questions on those two? Questions going once, twice, 3 times gone. Let's move along. We try letter A.
Wait, I want to break down F.
You got it? Notice that for letter 2A, for number 2A, we have a problem here. We have more than just E. We also have the 2, and we also have the 3. So now we want to be able to solve a little bit more complicated exponential equations. And so we have to move the 2 and the 3 and the E. Which one do you think you move first? 3. We could try to add 3 to both sides. Unfortunately, that would not work. If we had this expression, e to the 2x minus 3 is equal to 7, then you could add 3 to both sides. But right now, the 3 sits up in the exponent. We do get rid of the e first. In order to access the exponent, the e has to be gone. So if I have e to the 2x minus 3 is equal to 7, how do I get rid of a base of e? Natural log both sides. Thank you. And this beautiful thing happens where they cancel out and I get 2x minus 3 is equal to the natural log of 7. I have a natural log button on my calculator. I can compute that, natural log of 7, and I get 1.946. Don't be afraid of the decimals. You're going to get a lot of decimals in this section. How do we then solve? Add 3 and divide by 2, right? So I'll do those operations, and I get 2.473. Good? All right. How about letter B? I find most people get stuck on a problem like B. What do you want to do first? You could distribute the 2, or you could just divide the 2 off. So either option is fine. I would encourage you to divide the 2. I get 9 minus 12 to the 7 minus x is equal to, anybody, negative 934 divided by 2. Thank you. Next step. Subtract the 9 or add the 9? What remains on the left-hand side? Negative 12, 7 minus x to the 7 minus x is equal to negative 476. Okay, so this is important that we discovered this. You got this negative out front, don't you? Yes. So you don't do a negative base ever. Okay, what this says in this situation is that it's 12, notice order of operations, it's 12 to the 7 minus x and then multiplied by a negative 1. If it was actually a base of negative 12, it would look like this. That would create a base of negative 12. If there's not parentheses, then the negative is a multiplier. See the difference? So we divide both sides by negative 1. And we get 12 to the 7 minus x is equal to 476. We're not going to do letter C, so we can invade that space. Now, what do we do to both sides? Say it again. So I don't want to sound picky. You are 100% correct. I just want to make sure we're saying the right things because people have messed this up a little bit over the years. Just note that it's not log of 12 and it's not log times 12. It's definitely log base 12. See what I'm saying? So we're actually 12 is not an operation at all with it. We're describing the type of base. And the type of base we're using is a base 12. And I get 7 minus x is equal to, how do I compute log base 12 of 476? Yep, and note, again, that if I press natural log, you're going to get the same answer. So long as you use natural log for the top and bottom. The change of base formula just requires that the bases are the same. 2.481. Now what? Very good, subtract the 7. Negative x is equal to negative 4.519. So x is 4.519. You just to make a point that you can use log or natural log, so long as you use the same one for the top and bottom, it does not matter. Now, every once in a while, you got to stop and kind of smell the roses and look back at the original problem. Again, just think about that. When you walked into class, you didn't know how to do that at all, right? And now it's not that bad, is it? This next one, okay, we got these three and we're done for the day. But this 3 to the x plus 1 equals 2 to the 2x minus 3. This one's a head scratcher, folks. Now, what makes this one different than the others? You got two different bases. Excellent. If one base was 4, then we could do a 2 squared, right? But we ain't making 2 and 3 the same base, are we? That ain't happening. What do you want to do? Excellent idea. Base 6. Unfortunately, that will not help us. What if we just do this? What if we just drop those in front? Yeah. That's completely illegal, right? Yeah. Like if you had a logarithm, then you could do that. But that was completely illegal, right?
Yes, you can do that. That was cruel.
So let's just admit what's going to happen here, okay? If we do log base 2 of both sides, that'll work out fine for one side, but the other side will have the log base 2 of 3, right? And if we do the log base 3 of both sides, it'll work out great here, but over here it won't be so nice, will it? So let's just encounter the challenge that we have.
Why don't we just multiply like 3x plus 1 by 2 and 2x plus 3 by 3?
That's a great idea, but unfortunately the exponents win out in order of operation. We can't do that. You can't adjust the base until you do something with the exponents. So let's just embrace it. Log base 2 or log base 3. Kaylee, what do you want? Log base 2 or log base 3? You choose. 2. Got it. So we're going to do log base 2 of 3 to the x plus 1 equals, and then over here we're going to do log base 2 of 2 to the 2x. Whoops, stop that stupid. Log base 2 of 2 to the 2x minus 3. Yeah, so the good news for us is that this goes away, and we get just 2x minus 3 over there. So we like that. But the thing over here, not so pretty. Yes. So now, I tried to lead you guys through this. Very good job, Miss Wendy. She says, now that you have a logarithm, now why don't you just drop it down in front? So notice what we have. We have x plus 1 times log base 2 of 3. We could compute log base 2 of 3, couldn't we? I'd take my calculator and compute log base 2 of 3 by doing log of 3 divided by log of 2. And we get 1.585. So x plus 1 times 1.585. Now, I know that that's not real pretty because we got that decimal, but we know how to solve that, right? So let's just solve it. We distribute the 1.585. It's 1.585x. Now, do you want to move the x's to the right or to the left? What would you like to do? You want to go to the right? Okay. So minus the 1.585x. And I'll add the 3 over. When I add the 3, I get 4.585. Oh boy. And then if I do 2 minus, so 2 minus 1.585, I get 0.415. And then what? Yeah, so 4.585 divided by 0.415, and I get 11.048. It's kind of a tough one, huh? You want to see an easier one? Let's move to letter F. We'll get to E in a second. I had to rewrite E. We didn't like what it looked like before. Now I got like 3 things, and I got different powers, don't I? Does anybody recognize here that this is similar to another problem? Isn't it really similar to x squared minus 5x plus 4? Like, suppose that was your problem. What would you do? You just factor it, right? So you would have, x times x is x squared, and you would have negative 4 and negative 1, right? So what do you multiply to get e to the 2x? Isn't it e to the x times e to the x, e to the 2x? Because you would add the exponents, right? So if you had x squared times x third, that would be x to the 5th because you add these 2 exponents, right? So here, x plus x is 2x, right? I just made it up for an example. Okay, so then I have a minus 1 and a minus 4. So I will solve both of these equal to 0. E to the x minus 1 is equal to 0. So therefore, e to the x is equal to 1. How do I get rid of the e? Natural log of both sides. I get x equal to the natural log of 1. Hopefully there comes a point where you memorize the natural log of 1.
0.
It is 0 because think about it. It means e to what power is 1? And that would be 0. So it is. Then I solve the next one. E to the x minus 4 is equal to 0. I will add the 4. E to the x is equal to 4. Natural log both sides, and we get x is equal to 1.386. Yes, you have 2 solutions in that situation.
Where did you get the final one?
What?
Where did you get the final 1.3?
Took the natural log of 4 on the calculator? Sir?
So basically, when it comes to exponents, x2x is different from x squared.
2x is different from x squared. But e to the x squared is the same as e to the 2x. Because e to the x times e to the x is e to the 2x, or e to the x quantity squared. These are all the same.
Oh yeah, because they're multiplying exponents, not multiplying, not exponents.
You got it, buddy. Okay, last one. Scratch out e and write 3 over 4 plus 2 to the x plus 1 is equal to 10. Anybody? What makes this problem different from the others?
I can probably think of a few good reasons.
Yeah, it's the exponents now sit in the denominator, right? So this actually models some more real-world life type applications. Like we're going to look at the population of fish or rabbits and wildlife. As we model that, you definitely see this type of function come up. So how do you want to solve it? Good. Yep. Put the 10 over 1 and cross multiply. So 3 is equal to 10 times 4 plus 2 to the x plus 1. Now, a lot of people want to distribute that 10 through. I'm going to argue that it's just easier to just divide it off right away as opposed to distributing it through. Because sometimes when people distribute it through, instead of writing 10 times 2 to the x plus 1, they change this 2 to 20. And you can't do that. That's totally illegal. So let's divide by 10. And we get 0.3 is equal to 4 plus 2 to the x plus 1. Now what? So negative 3.7 is equal to 2 to the x plus 1. I do what? Log base 2 of both sides, so log base 2 of negative 3.7 is equal to log base 2 of 2 to the x plus 1.
And then you see the exponent.
So that goes away, leaves me with x plus 1. And anybody calculate for me log base 2 of negative 3.7? Why? Can't take the log of a negative, can you? So, in that situation, there's no solution. If I just simply change this instead of a 4 plus, if I change a 4 minus, we would have had a solution. But I wanted to make a point that you have to be ready that you can't take the logarithm of a negative number. Take out your worksheet.